Hello everyone, and welcome to our PrepScholar GMAT 700 Plus Data Sufficiency live stream. My name is Erika. You probably know me if you've been to this channel before. We're going to take just a couple of minutes to make sure everything's working okay, that our audio and our visuals are connected. This is our first time doing this. And then we're going to give people a chance to show up. So we'll start in a couple of minutes. All right, so it looks like everything is working a-okay. We're gonna go ahead and get started. So we'll start with kind of just some introductions about what's going on. Okay, so today's agenda, we're gonna start by doing kind of an overview of what we can learn from these specific hard data sufficiency questions. Then we're gonna talk about how we found these questions, how do we know they're 700 plus level questions. We're going to then go through each of those 5 hardest questions. Then we'll do a quick intro to PrepScholar GMAT, who we are, what we can do for you. And then we have a $150 tutoring code. So this provides a $150 value of free tutoring, and it's exclusive to webinar attendees. So stick around until the end and you can use that. And then finally, we'll do a Q&A. So feel free to use the chat. Oh, someone's in there already. Hi. And feel free to reach out that way. I'll try to answer your questions as we go. If not, I'll hit them in that Q&A portion at the end. Okay, so who we are. So Laura Lisinski is our PrepScholar GMAT director. We actually can't be in the same room right now because we're dealing with this terrible nor'easter here in Boston. But she's here in the chat. She might stop in at some point. She's a Wharton MBA alumnus, and she's great. And my name is Erika. If you've been to this channel before, you know who I am. I do the videos. I'm the PrepScholar GMAT content manager. And what this means is that I have led the production of all of the questions and the lessons, explanations, yada yada, in our online program. I am an experienced tutor and curriculum developer. I'm actually doing GMAT tutoring right now for PrepScholar. So if you use that $150 course code, you can get a class with me. And I have a 770 GMAT score. So I'll be presenting today and walking you through these 5 hardest data sufficiency problems. Okay. So what can we learn from hard data sufficiency questions? So the big points that we're going to talk about today are using visuals to simplify complex relationships. Oftentimes, the most difficult data sufficiency questions are very complex and they involve a lot of different relationships. And very often they don't give us much other than complicated sentences that we need to parse. So what we can do is we can use visuals to help us more clearly understand these relationships and then build out equations or solve using those. Another thing that we can do, in addition to using these visuals to simplify complex relationships, is to translate words into equations. And this, again, allows us to better understand the relationships between different ideas in the questions. And this, again, allows us to solve more easily. We're also going to look at a couple of strategies that we can use. One is plugging in smart numbers to prove statements insufficient. And then we're also going to talk about being comfortable using logic and making inferences. So kind of going against our first 3 points where we're, using visuals and making equations and plugging in numbers. At certain points on certain problems, using logic to get to our answers more efficiently and not necessarily proving it to ourselves can actually speed us up a lot and help us get through particularly complex problems. Okay. So moving ahead, how we found these 700 plus level data sufficiency questions. Okay, so we started with real GMAT materials. So on the GMAT website, they offer these GMAT prep exams, and we took those and we took advantage of the computer adaptive algorithm. So this algorithm basically, as you know, when you do well, it gives you harder questions. When you miss a question, it might give you easier questions. We had our experts go through and get all of the questions 100% right. And this led us to the hardest questions in the program. Then from those, we went through and we selected the ones that we thought were the most challenging, so ones that came toward the end. Then we went to online forums and just around the internet to confirm that students also struggled with these, that they were consistently considered to be 700 plus level. So from all of that, we came out with 5 of the hardest data sufficiency questions you could see on the GMAT. All right, so to start, we're gonna just assume that you know all of the answer options for data sufficiency. So statement 1 alone is sufficient, statement 2 alone is sufficient, both together are sufficient, each is sufficient on its own, and then together they are not sufficient. So we're gonna consider those A, B, C, D, and E. These answer choices will not be on the screen, so if you need to, grab a screenshot of this or pull it up on your computer separately, might be a good idea. Okay. So let's get started. Question number 1 is about a number line. So I'll give you a second to read through this, think about it on your own, and then we'll talk through how we can solve. Okay, so we'll go ahead and get started. We had a question about how long is this live stream going to last. It's scheduled to be about an hour. If people have a lot of questions, we could potentially go a little bit over with the Q&A, but we're going to try to keep it within that hour range. Okay, so this question, we're seeing it's about a number line that has 4 points on it, but we don't have a number line in this question. It doesn't give us a diagram. So this should lead us to think, okay, maybe we should draw out this number line. This is a really good tip for if we have a question that is dealing with shapes, graphs, number lines like this one, etc. It's really hard to visualize relationships without a visual. So if we have a visual, if it gives us a diagram, it's a really good idea to copy it onto your paper and then manipulate it, label it, move things around, etc. If we're not given a visual, we should, in general, make our own examples. Now, this question we could also approach by building equations, but since we have so many points and so many different values, the distance between A and B, C and D, we want to find B and D, these equations could get pretty complicated. So we're going to go ahead and start by drawing out our options. All right, so a key piece of information. These points are not necessarily in alphabetical order. I've seen this come up on quite a few math problems on the GMAT, so make sure to pay attention to just little phrases like this that will help us to solve. Okay, so because they're not necessarily in that order, we could have A, B, C, and D in that order, right? Where A to B is 18 and C to D is 8, but we could also have, okay, where B is between C and D, so A to B is 18, C to D is 8, or we could have this where C to D is right in the middle of A to B. So we don't know, but this is a good preliminary understanding of the problem. Okay, of course we could have more options as well, but those are just a few. All right, so statement 1, the distance between C and A is the same as the distance between C and B. Okay, so we know that C is 1 point, right? Now, if the distance from C to A is going to be the same as the distance between C and B, we can infer that C is actually going to be between A and B, directly in the middle. It's going to be the midpoint. So because A to B is 18, A to C is going to be 9, and C to B is also going to be 9. Okay, cool. Well, what does that mean about the distance between B and D? Well, we don't know anything about where D is. Other than that, the distance between C and D is 8. Now, it's critical to notice that distance is an absolute value. This means that D could be on this side, but it could also be on this side. We just don't know. So we could have either of these options. So D is on the left, which means that the distance between B and D is going to be 8 plus 9, or 17. or D could be on the right of C, which means that D to B is going to be 1. All right. So this statement alone is not going to be sufficient because the distance from D to B changes between these two options. So not sufficient. We're going to go ahead and eliminate A and D because statement 1 alone is not sufficient. Okay, statement 2. A is to the left of D on the number line. Okay, well, in both of these options that we've already created, A is to the left of D. So this actually didn't give us any more information than we already have. It's basically the same thing, you know. So we still have two options here, right? We can either have D to B is 17 or D to B is 1. So based on this work that we've already done, we can go ahead and say, okay, statement 2 is not sufficient, which means we can eliminate B. Alrighty, so now we're between both and neither, which is often where problems get the most tricky. But if we remember, both of these options were true with both statement 1 and statement 2, right? A to C is 9 and C to B is 9 in both of these options. And A to D, A is to the left of D here and A is to the left of D here. So both of these options are true given both of these statements. So we don't actually know given both of these statements, which means that we can pick E. So did we draw every single option that was possible for this problem? No, we did not. We ended up drawing about two whole options. But this actually saved us a ton of time because it allowed us to figure out, okay, there are two different scenarios in which both of these statements are true, where D and B is a different distance. All right, I got a question. Could D not be on the outside of A or B? So again, these are not the only options that we have. D could not be on the outside of A or B because it needs to be 8 away from C. And since A and B are both going to be 9 away from C, D has to be within the bounds of A and B. Exactly how much time should we spend on this type of question ideally? Again, it's going to depend on you and how long you can afford to spend on a problem at this point in the test. If you're already behind, then probably spend a little bit less time. In general, we try to spend about 2 minutes per quant problem. If you're really fast on problem solving, you may be able to give yourself a little more time on data sufficiency. So one thing to consider here is that we only drew out 2 options, and that meant that we saved ourselves some time. So we only need to prove that it's insufficient, which is a concept we'll get into later. So we only need to consider 2 options, and if we can prove that there are 2 different options for each statement, we can leave it at that. Don't have to spend any more time on an individual statement. Why can't A and B be on the same point? Great question. Because they are listed as 4 distinct points. They would not be 4 distinct points if they were on the same location. Okay, so might be some more questions later. We'll get to those in a minute, but we'll go ahead and move on to question number 2. All right, Bob's job. So go ahead and give this a read over. See if you can think about some of these relationships, and then we'll go over it together. Okay, so as we're reading through this problem, we might notice a few keywords. So we go, okay, if Bob produces 36 or fewer, all right, then he's paid X dollars per item. If Bob produces more than 36 items in a week, he's paid X dollars per item for the first 36 items and then 1.5 times that amount for each additional item. So we're getting some math words. Now, when we get these math words, it is a really good idea to turn these words into operators. So take our sentences and turn them into math equations. We can't really do math with sentences, but we can do math with equations. So what we can do is we can use these operator keywords to guide us through these sentences and translate them into equations. So when we have a number or fewer, we're going to be doing less than or equal to, more than, greater than, per or times. Again, we're going to have multiplication. All right, so using that, we'll go ahead and try to start building our equations. So we'll notice that we have two scenarios. We have a scenario where Bob produces 36 or fewer items, and then a scenario where he produces more than 36 items. So we're going to end up building two equations. So in our first scenario, he produces 36 or fewer items, and he's paid X dollars per item. So we'll go ahead and say, okay, if I, for items, is less than or equal to 36, then the total pay is going to be X times I, or X dollars for each item. Okay, let's move on to our second scenario. If Bob produces more than 36 items in a week, he's paid X dollars per item for the first 36 items. Okay, so if I is greater than 36, then we start out with a total pay with just a baseline of 36 times X, or for the first 36 items, he gets paid X dollars. But then after that, for every item after 36, he gets paid 1.5 times that amount for each additional item. So every item after 36, he gets paid 1.5X. So we can express this here. So for all of the items after 36, or I minus 36, he gets paid 1.5X. So that gives us our full equation for total pay after when Bob produces more than 36 items. Okay, now we can move on to our statements. All right, statement 1 tells us that last week, which is what we're trying to solve for, Bob was paid a total of $480 for the items that he produced that week. So we'll go ahead and replace total pay with 480. Okay, well, now what do we do? So at this point, it can be a really good idea to pick numbers. When we want to prove our statement insufficient, we want to try to prove that it can be true with two different options. So if we've got a value question where we're trying to find a value, we want to find two different values given the statement. If we have a yes or no question, we want to find an option where we get a yes and an option where we get a no. If you want more clarification on what a value question is versus a yes or no question, you can go ahead and watch our Intro to Data Sufficiency video, and you can take a look at that, just looking at your comments here. All right. So since we have a value question here, we're going to try to find two possible values for each statement. Okay, so if we want to prove something sufficient, we're going to have to establish a pattern. Now, one thing that we want to keep in mind when picking numbers is that we want to pick something easy. We want to be able to do this in our head, if at all possible, or easily on a piece of paper. Picking numbers is not useful if we just end up messing up our math. So we're going to pick something really, really easy. Okay. So we want to see if there are multiple options for I when the total pay equals 480. All right, so let's try some really easy values. Let's say we want I to equal 1. He only made one item. All right, so then 480 is going to be X times 1, which means that if X equals 480, X can equal 1. Okay, well, let's see. If we want to make I equal 2, then 480 will equal X times 2. So if X equals 240, then I can equal 2. So we were able to prove that I can equal either 1 or 2 just by plugging in very, very easy numbers. So since there are two possible values for I, even just with this first option, where I is less than or equal to 36, we can prove that statement 1 is not sufficient. So we did something else cool here. We totally avoided our difficult equation. We didn't even need to look at it at all. We used the simplest possible numbers, and we were able to prove that the statement was insufficient. We'll try this again for statement 2. All right. This week, Bob produced 2 items more than last week and was paid a total of $510 for the items that he produced this week. Okay, So we get a new value for total, but it's for this week. So we'll go ahead and pop 510 in for total pay. All right, so Bob produced 2 items more than last week. So let's come up with 2 scenarios and see if we can get different values for I. All right, so let's say I last week was equal to 0. Then I this week would equal 2. Then let's try a different scenario where I last week is 1, making I this week 3. So we'll go ahead and plug in 2 and 3 into our equations. And we'll end up finding that if x equals 260, then I can easily equal 2. Whereas if x equals 170, then I can equal 3. So again, just using this first very simple equation, we were able to prove that there are 2 possible options for how many items Bob produced last week to get a total of $510 for the items he produced this week. So again, this statement, not sufficient. Okay, now we're going to try to combine these 2 statements. So we know that this week Bob made $510, and last week he made $480. We also know that he produced 2 more items this week than last week. So that means that those 2 items make the difference between 510 and 480. So he made $30 for those 2 items. Now, what rate did he make those items at? Well, if last week he made less than or equal to $34, then both of the items for this week would still be in this first equation. It would be less than or equal to 36 items. So he would have made X dollars per item. This means that 2X would equal 30, and X in general is 15. So he would have made $15 for each item. However, if we're thinking about this second equation, so if last week he made more than 36 items, then this week both items would be made at this raised rate of 1.5. So that means that X is going to equal 10. Now, if last week he made 35 or 36 items, then one of the items, those 2 items would have been made at this rate of X, whereas the second item would be made at this rate of 1.5X. Which means, again, that X is going to equal 12. So we have 3 different options here. Now, just given that we have 3 different options, we can probably predict that we're going to have multiple possible values for I. But let's go ahead and try it. Again, we only want to find 2 different values for I. We don't need to find a third. We just want to prove it insufficient. So we'll go ahead and try our first one. All right, so let's say X is equal to 15. Let's plug that into our equation. So again, we want to find the items he produced last week, so we'll go ahead and plug in this 480. So if 480 equals 15 for X, I, then I is going to equal 32. So if he produced less than or equal to 34 items last week, then I is going to equal 32. All right, let's try our next scenario. If I of last week is greater than 36, then X is equal to 10. So again, let's plug that in. All right, this one's a little bit harder, right? Because we're dealing with a more complex equation. But if we go through and do all this math, we find that I can equal 44. So if X equals 10, I will equal 44. So we could go on to do our third equation, but we actually don't need to. We were able to find 2 different values for I that satisfy both of these statements. So given this, we can go ahead and say, all right, it's not both. We still have 2 possible values, so we're going to end up with neither. So again, we didn't have to deal with our more complicated equation. All right, looking at your comments. All right, any questions? So for those of you who are feeling a little bit overwhelmed by these problems, that's okay. These are definitely really challenging. They are 700 plus level. If you want to practice these 700 plus level questions, stay tuned and we'll do a few more of these, but definitely practice at your own level. If you're not quite here yet, it's more valuable for you to spend time with questions at your level. Yeah, exactly. So Mustard Pocket, it made a really good point, which is kind of what we were saying earlier. Once we have the information that x can equal multiple values, we can pretty confidently say that I is going to equal multiple values as well. But we did plug it in just to be totally sure that it doesn't somehow come out to the same value. All right. Okay, so we'll go ahead and move on to question number 3, which is our patios and pools question. Take a look at this. If you've watched a lot of our videos, you might recognize this question type. See if you can figure out how you might solve, and then we'll go ahead and solve together. Okay, so if you're looking through this question, you might notice some keywords, especially if you've watched our overlapping sets video. So if you look at these statements, we go, okay, there are a bunch of options. So there's the option of having a patio but not a swimming pool. There's the option of having a patio and a swimming pool, the option of having neither, and I would assume also the option of having a swimming pool but not a patio. So we've got two possible properties here, two characteristics, having a patio and a pool, and sometimes they overlap. So this gives us the hint that we're dealing with an overlapping sets problem. So keywords here would be either, neither, only, or both. Now, if you want kind of a primer on these overlapping sets, definitely go take a look at our overlapping sets video, but we're going to kind of cover how to do this here. So when we have overlapping sets, we almost always want to use a visual to help us understand and piece together how these complex relationships matter and how that allows us to solve. So with overlapping sets, we have one group with multiple traits. So in this case, we have two traits, patios and pools. So we're going to go ahead and use a double matrix, which is basically a table. Now, if we have three traits, we want to go ahead and use a Venn diagram. But here, we only have two, so we'll deal with that. All right. So we've gone ahead and set up a double matrix where we've got whether or not you have a patio on the top and whether or not you have a pool along the side. So we have these cells in the middle, right? So this cell will represent all the houses that have both a pool and a patio. This one will be a pool but no patio. This will be total with a pool. This will be total, just total, etc. All right, so now using this, we're going to go ahead and fill in the information we know and see what kind of relationships we can figure out. So again, we're using a visual, just a different kind. Okay, so we know that there are 75 houses in total. So we'll go ahead and put that in our total cell. All right, we also know that 48 houses have a patio. So we'll put that in our total patio cell. Okay. We then want to find the number of houses that have a swimming pool. So we don't know what that is. We want to solve for it. So we'll go ahead and represent that as X. We'll put that in our total pool cell. All right, now can we figure out anything else from this? Well, okay, we know that the total number of houses is 75 and the total number of houses with a patio is 48. So that must mean that 27 houses, or 75 minus 48, have no patio. Okay, that's about all we could figure out. We could fill in 75 minus x here, but since we don't know what x is, that's not very helpful. So we'll go ahead and move on to statement 1. All right, statement 1 says that 38 of the houses in the community have a patio, but not a pool. So we'll go ahead and pop that information in right here, which gives us a column where we have 2 values and then 1 missing one. So we know that we can fill in this with a 10. Because 10 plus 38 equals 48. All right, can we fill in anything else? Well, not really. We could fill in x minus 10 for pool but no patio, but since we don't know what x is, again, that doesn't help us very much. So we can go ahead and rule out A and D because statement 1 is not sufficient to figure out what x is. All right, moving on to statement 2. We went ahead and took out that 38 or 38 right here because we don't have that information anymore. Okay. The number of houses in the community that have a patio and a swimming pool, so this, is equal to the number of houses in the community that have neither a swimming pool nor a patio. So here. Okay, so it doesn't give us any specific values for these two, but it does say that they're equal. All right, so what can we do? Well, kind of going on our building equations tip, we can go ahead and fill in this value that we don't know with a variable. So we'll go ahead and say that that's n. And we know that n is going to be the same because the statement told us so. All right, well, now we have even more variables. What can we do at this point? Well, we should notice something interesting. We have an empty cell here in a nearly complete row and a nearly complete column. So just kind of playing with this for a moment, we can actually say that this value here is going to be equal to x minus n, but it's also going to be equal to 27 minus n. All right, so that means that these two values, x minus n and 27 minus n, are equal. Well, if we go ahead and pull that out as an equation and then add an n to both sides, we end up with x equals 27, as a couple of people predicted in the comments. Nice work. So this is actually a pretty complex overlapping sets problem. Oftentimes we'll just be able to fill in everything and we'll end up with a number. But here we actually had to build an equation within our diagram. So this is particularly complex. So congrats to everyone who got this one. So our answer is going to actually be B. We only need the second statement to figure out this problem. All right, let's see. Any other questions? All right, a lot of people got this one right. Nice work. Okay, so good work on this one. We'll go ahead and move on. If, again, you weren't entirely clear on how this one works, go ahead and watch our overlapping sets video. It talks about how we do this in much more detail. All right, this one is particularly nasty in my opinion. So go ahead and take a look, see if you can kind of wrap your head around what's going on, and then we'll go ahead and solve. All right, so before we actually move on to this one, got a question about how 27 would make the statements conflict. We'll actually go back and take a look at this one more time. So we know that 38 of the houses in the community have a patio but don't have a swimming pool. So that would make this value right here 38, which would make n 10, which means that 27 here actually isn't bad. So this value right here would be equal to 17. So actually these statements don't conflict. If you want to actually take a closer look at this one and go ahead and solve it for yourself, we'll post this live stream afterward and you can take a closer look at this one. But no, the statement should not conflict on this one. It's an official GMAT question, and official GMAT questions, the statements never conflict. Okay, moving back on to question 4. Good catch though. We have something pretty complicated here. All right, so we may notice, oh, either and both. that indicates to us, okay, maybe we should do an overlapping sets visual here. But we should notice a couple of things here. All right, so each employee of company Z is an employee of either division X or division Y, but not both. So there is no scenario where X and Y overlap. We also know that you have to be either in division X or division Y, so there's no scenario where there's neither, right? Same thing with part-time and full-time. You have to be either part-time or full-time. There's no overlap. So we're seeing that there's not actually that much overlap between these things. We also notice here that there are no values whatsoever. So if we go ahead and build out our if we go ahead and build out our visual, we'll be able to build some cool equations from it, but it actually doesn't tell us anything about actual values. So we may want to save ourselves some time and not build a visual on this one. Kind of your choice. If it helps you to understand the relationships better, might be helpful, but I'm going to go ahead and not do one. All right, so let's see. We also have this word ratio. Now, ratio should indicate to us, okay, we're going to go ahead and build fractions. Ratios and fractions are the same thing, but it's much easier to work with fractions. So we're going to go ahead and build with that in mind. Okay, we also see a lot of these words, greater, less than, more than. So we should be thinking, okay, inequalities. So we know, all right, we may have some overlap here. Maybe we've got ratios and we've got inequalities. Okay, so knowing that, let's go ahead and try to build an equation. So I went ahead and put this on the screen a little too early, but if we think about this, we want to know if the ratio of the number of full-time employees at division X to the number of part-time employees at X is greater than the number of full-time employees at Z to the number of part-time employees at Z. So we can go ahead and build this out as a fraction. So this is our ratio of full-time at X to part-time of X, and we want to know if it's greater than the ratio of full-time at Z to part-time at Z. Oh, we've got a question. Will this be available later? Yes. So if you need to dip out at any point, totally fine. We're going to post this to our channel. The only thing that you won't be able to do is, yes, it will be on this channel. The only thing that you won't be able to do is participate in this chat and get these questions answered live, but I will be trying to respond to comments as quickly as I can. So if you want to check this out later, you can. All right. So we've gone ahead and built out an equation for what this question is asking us. And if we can answer either yes or no, that this is true or not true, then the statement will be sufficient. Okay. Moving on. Statement 1. The ratio of the number of full-time employees to the number of part-time employees is less for division Y than for company Z. Okay, so we get another inequality here. So we're gonna go ahead and write that out. So we express our ratio as a fraction again. So full-time employees at Y to part-time employees at Y is going to be less than full-time employees at Z to part-time employees at Z. Okay, so does this tell us anything? We notice that here we're dealing with division Y, right? We want to know about division X. So how can we turn this into something about X? All right. So we know from this first line that the number of employees at X plus the number of employees at Y is going to be equal to the number of employees at Z. This means that full-time at X plus full-time at Y will equal full-time at Z. And part-time at X plus part-time at Y will equal part-time of Z. So what we can do is we can express full-time at Y and part-time of Y with full-time of Z and full-time of X. Sorry, this is very hard to say. So we can express full-time at Y as full-time at Z minus full-time at X. And we can express part-time at Y as part-time at Z minus part-time at X. So if we go ahead and fill that in, we end up with this new inequality, where we notice that we have full-time at Z, which is the same as over here, minus full-time at X, and part-time of Z, which is the same as over here, minus part-time at X. Okay, so what can we do with this information? We might be tempted to go ahead and start manipulating this inequality like crazy, start doing a bunch of math. But let's take a second and pause. If we want to avoid unnecessary math, it's often a good idea to be comfortable making inferences. So not everything needs an equation. We don't need to prove everything to ourselves by getting x equals something. Sometimes we need to use logic to answer our own question. So let's go ahead and think about this one logically. Now, when we have a fraction, how can we make a fraction larger or smaller? Well, if we want to make a fraction smaller, we're going to want to decrease the numerator more than we decrease the denominator. Or we want to increase the denominator more than we increase the numerator. And this will make our fraction smaller. So here, we're taking away something from both the numerator and the denominator, right? Now, if we want the numerator over here to be smaller than the numerator over here, more than this denominator is smaller than this one, we know that we need to be subtracting more in this numerator than we're subtracting in the denominator. So that means that this must be greater than this. So what this actually tells us is that our ratio of full-time at x to part-time at x is going to be greater than our ratio of full-time at z over part-time of z. So this takes a little bit of thinking through. If you want to think about this a little bit more, again, this video will be posted later and you can stare at this to your heart's content. But going through and doing this logical reasoning allows us to eliminate all options B, C, and E, because statement number 1 is sufficient to tell us that this ratio of full-time to part-time at x is greater than this ratio of full-time to part-time at z. Now, if we wanted to go ahead and prove this to ourselves, we could go ahead and do this math. Now, it's kind of nasty. So basically what we do is we multiply both sides by the denominators, and then we can eliminate like terms, multiply by -1, which flips our sign, and then divide everything by part-time at x and part-time at z, which again gets us this same equation. So if we go through and do math, we get the same thing. But again, if we think logically, we can skip all of this. If we think logically, we can just go ahead and determine that this must be true, no matter what our math says. So either way we approach it, we can go ahead and say statement 1 is sufficient on its own. All right, let's see if we can approach statement 2 in the same way. All right, more than half of the full-time employees of company Z are employees of division X, and more than half of the part-time employees of company Z are employees of division Y. Okay, so this tells us full-time at X is greater than half of the full-time at Z, and part-time at X is going to be less than half of part-time at Z. So we kind of did a bit of an inference here, because more than half of the part-time at company Z are employees of division Y. That must mean that less than half of the part-time employees at company Z are part-time of X. So based on this, okay, what can we do? Well, again, we want to set up a ratio. We want to set up our fraction. So let's go ahead and do that. So if we've got full-time of X over part-time of X, that's the same as saying, okay, some number greater than half of full-time at Z over some number less than half of part-time at Z. So if we eliminate the half, we have, okay, greater than full-time at Z over less than part-time at Z. Okay, let's think about this logically. So full-time of X is greater than full-time at Z. So that numerator is greater. And this denominator, part-time at X, is less than the denominator, part-time at Z. So we've got a larger numerator and a smaller denominator. So that leads us to a larger fraction in general. So just based on logic, we can determine that full-time at X over part-time at X is going to be greater than full-time at Z over part-time at Z. So again, this is going to be sufficient. And we can go ahead and pick D. Both statements are sufficient on their own. So again, if we wanted to go ahead and do a bunch of math, we could. It's a little bit more complicated for this one. But if we're more comfortable with making these sorts of inferences, then we can go ahead and solve this problem much faster. So I think this one is a significantly more complex question than some of the others. So if you want to spend a little more time with it, I highly recommend revisiting this video later. Any questions? Let's see. All right, if this is too slow for you, you can definitely watch this later at a higher speed, which was suggested in the comments. We're trying to keep this slow enough that folks can follow along at home. But if you're doing just fine on these and going efficiently, great job. Then you're probably working at a 700 level already. So that's awesome for you. All right, so we'll go ahead and move on to question number 5. And if you can figure this one out in advance, go ahead and throw your answer in the comments, and we'll see if you get it right. All right, so we can play this as kind of a game. All right, so question number 5 is about remainders. So go ahead and give this one a read. It's a little bit quicker, and then we'll solve it together. Okay, so getting started with this one. All right, we'll probably want to notice right off the bat that we know that n is a positive integer. Like in that first question, little pieces of information, like if something is positive in an integer or if numbers are not necessarily in an order, are often critical to solving. So we'll go ahead and just make a note that this is going to be true. Okay, so we're going to go ahead and try to build an equation like we did before. So we want to take n minus 1 times n plus 1 and divide it by 4. And we're going to get some mystery number, which we actually don't care about. We don't care what the number we're dividing by, what our quotient is. What we care about is what our remainder is. So we want to find one value for r. Now, as we talked about earlier, when plugging in numbers, all we want to do is we want to prove that we can have 2 values for r. We don't care if there are 3 or 4 or 5 or 1,000. If there are only 2, that is enough to prove something insufficient. So this is a great candidate for number picking, so we'll go ahead and approach it that way. All right, number 1, n is not divisible by 2. Okay, so what does that mean? If we rephrase that, all this means is that n is not even, so n is definitely going to be odd. Okay, so we can think about number properties, but this might be a little bit confusing and get a little too cerebral. So let's just go ahead and plug in some very easy values for n that satisfy the statement. So if n is odd, let's say, okay, n equals 1 and n equals 3. Donezo. All right, so when we go ahead and plug in these values, we're going to get 0 for each, right? We're going to have a number smaller than 24 in the denominator. So here it'll be 0, or sorry, not in the denominator, in the numerator. We'll get 0 here and 8 here. So our answer will be 0. But when n equals 1, our remainder is 0, and when n equals 3, our remainder is 8. So we have 2 different remainders. This was incredibly easy. We plugged in 1 and 3, and we were able to determine, no, this statement is not sufficient. So we'll go ahead and eliminate A and D and move on to statement 2. Now let's see if we can use any of the work that we did for statement 1 to solve for statement 2. Okay, so n is not divisible by 3. All right, so 1 is not divisible by 3. We'll keep this one. So we know that r can equal 0 and satisfy this statement. But n equals 3 is divisible by 3, so we'll get rid of that one. All right, let's try a really easy number that's not divisible by 3, like 2. All right, if we go ahead and plug this one in, we get 3 over 24. So the answer is going to be 0 again, but the remainder is going to be 3. So again, 2 different remainders, not sufficient. So we'll go ahead and eliminate B. All right, bringing these 2 together. All right, we want a number that is odd, but also not divisible by 3. All right, so n equals 2 is going to be out of there. because it is divisible by 2. All right, so what's our next number? N equals 5. Okay, so let's try plugging that in. Well, that's interesting. When we plug in n equals 5, we end up with 4 times 6 over 24, which is 24 over 24, which equals 1, remainder 0. So here we have, remainder 0 2 times in a row. Now, we discussed earlier, when picking numbers, we only need to find 2 different numbers to prove that something is insufficient. But if we want to prove that something is sufficient, we need to find a pattern. Now, we're not going to be able to plug in every single number, right? But we want to prove in enough to justify to ourselves that we can trust that every single time we plug in a number, we're going to get that same answer. So 2 is not enough. This could be a fluke. So we'll go ahead and try another one. So we'll try n equals 7. All right, if we plug that one in, oh man, 6 times 8 over 24 is going to be 48 over 24, which is 2, remainder 0. All right, this looks like a pattern. Cool. All right, we'll try one more. N equals 11, plug that in. We end up with 5, remainder 0. All right, this is enough to prove to ourselves, hey, we're going to get a remainder of 0 every single time we plug in a number that is not divisible by 2 or by 3. So we can together figure out that r is always going to equal 0 and that both statements together will be sufficient. All right, so let's go ahead and look at these comments. Yeah, exactly. So a bunch of folks are figuring out this pattern, right? So we only needed to plug in like 4 numbers. At this point, we can say, okay, this is enough. We don't need to plug in anymore. So we were able to prove this sufficient. Alrighty, so those are our 5 questions. So the big takeaways here are that we want to use visuals to simplify complex relationships, whether that's drawing a number line or a shape or a graph or doing a double matrix. This can really help us to clarify some complex word problems. Another thing we can do to clarify complex word problems is to translate words into equations. So we did that on a couple of our problems. Once we have those equations, it can be a really good idea to plug in smart numbers to prove our statement's insufficient. So to prove insufficient, we want to get 2 different answers, so 2 different values, or a yes and a no. Then at that point, we can stop. If we want to prove the statements are sufficient, we definitely want to find a pattern. So we want to find that consistently we get that same value or that same yes or no. Now, finally, we also want to think about being comfortable using logic and making inferences. So sometimes going ahead and making these complex equations or diagrams or whatever else can waste a lot of time. So when we think about this logically and try to rely on our brains a little bit more, sometimes we can skip a bunch of more complicated, nasty steps. Alrighty, so those are our 5 problems. Really quick introduction to who we are. So we're PrepScholar GMAT, and we make these online videos, but we also do other stuff. We have an online program, and this online program has questions adapted from real GMAT questions. So they're the most accurate questions you're going to find outside of stuff presented from GMAT. Now, these questions are built into an adaptive study schedule. So basically what that means is that you're going to be getting the questions and the lessons and the practice tests, etc., that are built best for you. So if you're already at a 700 level, like some of the folks in our comments, you'll be getting the most challenging questions out there and lessons that are built for your level of difficulty. Now, if you struggled a little bit more with these, you'll be getting the questions that are specifically built for your level. It also includes practice tests that are published by the GMAT, so the real deal. So that'll be both the real adaptive technology and real GMAT questions. And then we have lessons and explanations and video explanations from instructors that know the GMAT inside and out. So folks that graduated from top universities and MBA programs that have a bunch of experience and top 1% GMAT scores. Now, what y'all came for. If you are listening to this, you get a special code, and this allows you to get a free hour of tutoring with the purchase of our online program. So this code is tutor123. This free hour of tutoring is $150 value. So basically this means that with this purchase of this $399 course, you get $150 value of tutoring. So again, these tutors, like our instructors, are going to be experts on the GMAT. I'm going to be one of them, so it's possible you could get a course with me. So we could go over some of these questions from today, go over questions from the PrepScholar GMAT program, go over questions from your own practice tests, etc., etc. Now, if you want to take advantage of this code, you'll go ahead and enter it at checkout. So you'll see something like this. And notice that it's a 5-day free trial. So if you go ahead and decide after the 5 days, no thanks, not really worth my time, we won't bill you. So if you want to go ahead and take advantage of this, you can pop your coupon code in right here. Now this code is going to be valid until the end of March, so until March 31st. So if you want to go ahead and use it, take advantage of it now. Again, it's a 5-day free trial, so it's totally risk-free. If it doesn't end up being for you, we won't charge you. Okay, any questions? So if you have any questions on the problems or any questions on PrepScholar GMAT in general, I'd be happy to answer those now. Go ahead and throw those in the chat. All right, we've got a request for number systems. Cool. Thank you for your request. We always appreciate folks commenting in the comments or sending us messages about videos that you'd like us to do. We'll go ahead and put that on the schedule. Some questions from geometry. Okay, awesome. We'll go ahead and put that on the schedule as well. All right, and if you have any other questions, of course, you can always hit us up at gmat@prepscholar.com. You can ask questions about the program, and we'll be happy to get back and answer you. Awesome, lots of great suggestions in the comments. Thanks, guys. Okay, got a question about what you should do when you're going to take the GMAT. You only need to bring your ID. Yeah, basically, don't bring anything that you don't need. So you can bring snacks, you can bring medication, and put those in your locker, but that's gonna go in your locker. You can't bring that into the exam room. But there's actually, let me go ahead and get you guys a link. Let's see. I'll just provide you with a link from GMAT that says what you can and can't bring on test day. Because there's a lot of stuff you can't bring, and that's pretty important. All right, so there is a link for what to bring on exam day. Go ahead and bring that a look, because it would be really unfortunate if you didn't bring something that you need, so maybe the wrong form of ID, or if you did bring something that you can't have. All right, yeah, we're getting a lot of requests for geometry. Awesome, yeah, geometry isn't quite as heavily tested on the GMAT as it is on other exams like the GRE, but when it is tested, it's often tested from a very logical perspective. So your ability to take these equations and work logically with them. So great request. We'll go ahead and try to put that on the schedule as soon as we can. Coordinate geometry as well. Awesome. Let me actually, I think we have a great blog article that deals with equations that you want to know for the GMAT. Let me see if I can find that for you and link that in the chat. All right, so here's an article from our blog about geometry formulas. that you might want to know for the GMAT. It says it's every geometry formula you need to know. And then here's another one with just a bunch of GMAT formulas that you might need to know. So hopefully that helps out with what you're looking for in the meantime, and we'll try to get that video up for you as soon as we can. All right, got about a minute more. If you have any questions, throw those in the chat now. If not, you can always, again, email us, gmat@prepscholar.com, or you can go ahead and comment in the comments on this video once we go ahead and post it on our channel. And let me go ahead and pop that code up here one more time. Again, that's tutor123, and that's a $150 value. It's a free hour of tutoring with the purchase of our completely customized online course. The course on its own is a great value, and the tutoring can be highly, highly effective. So I highly recommend you take advantage of this opportunity. Again, totally risk-free if you decide not to purchase. And this tutoring can be with me or with another GMAT expert. Okay, everyone, thank you so much for attending today, and thank you for all of your great questions and suggestions. Again, if you have more, feel free to leave those on the video itself. Thanks again. I've been Erica, and we're PrepScholar GMAT. Hopefully we'll do this again soon.